Hello and welcome to our webinar that helps you get familiar with ECHA's guidance to assess the risks of biocides to bees. I'm Adam Malwan, your host today. So to get us started, these are some of the things you can expect today. First, you'll be getting a better understanding of when to assess the risks of biocides for bees. Our presenters will also be going through the methodology and decision schemes that need to be followed when doing your risk assessment. And last but not least, you'll have the opportunity to ask questions from the experts that have joined us today, so do make use of that. You can send your questions throughout the event by going to slido.com and using the event code ECHABees, or you can also use the QR code visible on this slide. Your questions will be answered during the live Q&A. You can also upvote questions, and I really recommend using this feature so that we do cover those questions that are most relevant for you. If you have a question directly to one of the speakers, add their name so that we know who to address it to. Now, we can only cover questions within the scope of the webinar. That said, if you do have questions that are not directly related to the topic, you can still send them to us using our contact form at echa.europa.eu/contact. A Q&A document with answers to all the questions we receive will be published after the event. If your question is not answered by the time we close, you'll find your answer in the published Q&A. The presentations are already available on our website, and the video recording will be there soon after the event. As mentioned in the previous slide, we'll be replying to all the questions we receive. Those we have time for during the live Q&A, and the rest in the Q&A document published shortly. Now, the ECHA guidance has been developed by a group of 21 experts from Switzerland, the Netherlands, Spain, Norway, Germany, Austria, and ECHA, together with experts from EFSA. Today's webinar will be given by 6 experts from the group. So this is our program for today. We'll start with Jana from ECHA, who will introduce you to the guidance. Then, Tenzin Gyalpo from the Swiss Federal Office for the Environment will take you deeper into the scope of the guidance and the risk assessment scheme for bees. Adriana from ECHA will then take you through the exposure assessment, covering the main sources of exposure and the relevant mathematical models for exposure assessment. After Adriana, we have Petra Kunz, also from the Swiss Federal Office for the Environment, who will talk about the information requirements for effect assessment, available test guidelines, and lower-tier risk assessment. Petra will be followed by Maria Amarca from the Swiss Federal Environment Office, who will talk about applying the concept of time-reinforced toxicity and the strategy and data requirements for assessing sublethal effects. Our last presenter today is Ella from ECHA, who will guide you through the approach for metabolites and mixtures, followed by conclusions from the webinar. All right, it's time to give the floor to our first presenter, Jana Laitinen, on ECHA's guidance. Jana, over to you.
Hi, I'm Jana Laitinen, Scientific Officer at the European Chemicals Agency. In this presentation, I will give an introduction to the ECHA guidance on the risk assessment of bees from the use of biocides, and I will also explain some aspects on the development project of this guidance. So first, a brief look to some background information, such as what are the pollinators that were considered in this guidance project, and why do we need this guidance for the risk assessment of pollinators. As it's well known, bees and other pollinators are very important in the environment, for example, for the food production, but also for the general preservation of biodiversity. And at the same time, however, there is a well-known global decline in the insect pollinators. And for these reasons, action is needed to protect these organisms. And in the EU, there is the Pollinators Initiative, which is addressing these concerns. And it also contributes to other initiatives, such as the EU Green Deal. And here, chemical pollution has been identified as one of the major threats to wild pollinators. And for these reasons, it is important to also assess the risk from biocides, so that any harmful substances and uses of biocides can be identified and relevant action can be taken to protect pollinators. And in the frame of this guidance project, the insect pollinators that were considered include bees, honeybees, bumblebees, and solitary bees, and also other insect pollinators or so-called non-bee pollinators, which can be divided into 4 main groups that are flies, moths and butterflies, wasps and sawflies, and beetles. So looking back at the current or previous guidance that has been available for biocides, there is actually not that much instructions available how to perform risk assessment for pollinators. Basically, the previous guidance has stated that there is no method available for biocides, and therefore a qualitative risk assessment should be performed if data is available. And that data would be required, for example, on substances that are used in large-scale outdoor applications. And since the guidance has been very limited, this has led to a number of questions on how to perform the assessment in practice. For example, how to perform a quantitative assessment, what are the relevant application types and uses, and what are the exact toxicity studies that would be required for the assessment. So therefore, together with the growing concern on the pollinators, a need for more detailed guidance was identified. Then in 2019, a mandate was received from Commission where ECHA was requested to develop a guidance for assessing risk to arthropod pollinators, including bees. So the arthropod pollinators mainly refer to insect pollinators, which are a subgroup of arthropods and are recognized as an important group of pollinators. So this means that under the mandate, both the bees and the non-bee pollinators should be addressed. And secondly, under the mandate, there was a request to specify the information required to perform the assessment. And in this presentation, I will first describe the approach for bees, and in the end of the presentation, I will explain how the non-bee pollinators were addressed. So first on bees, under the mandate, ECHA was asked to take into account any available information from EFSA on the plant protection products with the aim to harmonize and align the assessment between plant protection products and biocides. Therefore, it was decided that in the ECHA guidance, the same risk assessment methodology should be used as outlined in the guidance for plant protection products. It should be, however, noted that the EFSA guidance covers only bees, meaning that the non-bee pollinators are not included in that document. And also, secondly, it was not possible to apply the guidance on the plant protection products directly in the assessment of biocides due to the differences between these frameworks, especially related to the exposure part. And therefore, there was a need to develop specific guidance for biocides. So when applying this risk assessment methodology from the guidance on the plant protection products, there were some new concepts introduced into the risk assessment of biocides. In the biocides regulation, the environmental protection goal is defined in broad terms, as it's referring to unacceptable effects on the environment, on the biodiversity, and on ecosystem. However, the specific protection goal provides a tool which can be used to define those goals in a more concrete terms. For example, the bees are considered as providers of the pollination ecosystem service, and then the specific protection goal is defined via the strength of the bee colony or population. So the underlying assumption is that the more broad protection goal can be achieved via protection of the ecosystem services. For honeybees, a value of 10% is defined as the maximum permitted level of colony size reduction following chemical exposure, and this value is then used in the quantitative risk assessment as a threshold in that assessment. For bumblebees and solitary bees, this value has not been defined yet. Then, as an outline of the ECHA guidance for the risk assessment of bees, in chapters 2, 3, and 4, we provide the overall scheme for the risk assessment, and also it is described how the methodology from the plant protection products is transferred to the biocide assessment, and also the relevant sources of exposure from biocides are explained. In chapters 5, 6, and 7, the methodology is described on how to perform the exposure assessment, the lower tier effect assessment, and lower tier risk assessment. Then moving on to chapter 8 and 9, these chapters explain how to perform so-called time-reinforced toxicity assessment and assessment of sublethal effects, which are new elements in the biocide assessment and specific for the bee risk assessment. There is a short chapter on the higher tier risk assessment, and in chapters 11 and 12 we provide a specific scheme for the assessment of metabolites and also biocidal products as mixtures. In addition, in chapter 13, the risk mitigation measures are described briefly, and we also mention the warning sentence, which is required when a biocidal product contains an active substance that is hazardous to bees. And for the warning sentence, more information can be found in a separate biocide competent authority document that was adopted in December 2023. Then coming to the non-bee pollinators part, in the frame of this guidance development project, it was not possible to propose a risk assessment scheme due to a number of data gaps that were identified. However, there is a separate scientific report published in 2022, and this report provides results from a literature and a database review and explains in detail all the data gaps that were identified. And these include, for example, lack of standard test guidelines on the non-bee pollinators, also lack of information on the basic ecology and biology of non-bee pollinators, and for example, lack of information on the most relevant route of exposure of these pollinators. So even though at the moment it was not possible to propose a risk assessment scheme for the non-bee pollinators, this report is an important starting point for the future development of the guidance. And the guidance exposure group has already considered that the non-bee pollinators will be covered under the non-target terrestrial arthropods assessment in the biocide guidance. And with that, I come to the end of my presentation. Thank you for listening.
Hello, I am Tenzing Gyalpo. I'm working as a scientific officer at the Swiss Federal Office for Environment in the unit responsible for the environmental risk assessment for biocidal products. In this presentation, I will introduce you to the scope of the ECHA guidance on how we have selected the relevant biocidal applications and emission routes which lead to potentially exposure to bees. Secondly, I will show you how the bee exposure pathways are connected to the toxic effects. And finally, I will close with giving you an overview of the risk assessment schemes for honeybees. Biocidal products can be applied in many different ways and in many different places. Therefore, only few of them can be compared to the uses of plant protection products in agricultural fields. Therefore, for biocides, there could be potentially many different routes and levels of exposure of bees to the active substances. As you can see here, biocides are divided into 22 product types, which belong to the four main groups: disinfectants, preservatives, pest control, and others. What we did is we screened all the uses described in the harmonized guidance documents of all product types by applying the criteria listed on the right side. This way, we could rule out biocidal applications and emission routes for which the exposure of bees is not likely. With this pragmatic approach, it became apparent that we would focus on the product type 18, which include insecticides, acaricides, and products against other arthropods. Based on this screening and the consultations done with the member states and the accredited stakeholders, we could finally identify 4 sources of exposure that would trigger a complete bee risk assessment. And the 4 sources of exposure are the following: the application of manure and sludge from animal housings on agricultural fields, spraying on walls and foundations of buildings, the irrigation of private garden with treated water, and finally the large-scale spraying of trees, bushes, and water bodies. What those 4 sources of exposure have in common is that the scale of the treatment is rather large scale, and the active substances are released and emitted to an environment that is potentially attractive to bees, and that is the soil compartment. In the ECHA guidance, the basic assumption is that the contaminated soil is covered with vegetation, and this vegetation is assumed to be attractive to bees. We also looked into other rather small-scale outdoor uses, namely the bait and spot application on terraces, the application on wasp nests, and the potential direct consumption of bait products by honeybees. For the first 2 uses, a very small area or a very small vegetation area of less than 10 square meters is contaminated according to the guidance documents. Therefore, it is very unlikely that the bee colony size would be significantly affected by this type of application. The direct consumption of solid baits is not assessed because the attractiveness of bait products for bees is rather low based on the literature data and the feedback from accredited stakeholders. Bees prefer sugar in liquid form, and furthermore, as long as there are alternative food sources such as honey, nectar, or pollen, bees would always prefer those natural sources over sugar-containing baits. Now, how are now the sources of exposure connected to the toxic effects in bees? The sources of exposure lead to emission to the environment, resulting in contaminated soil, contaminated non-flowering plants, and contaminated plants in flower. And bees, they will take up those chemicals either by the consumption of contaminated pollen and nectar, or they get into contact with the chemicals either during or shortly after the spray application. And these two bee exposure routes, the dietary exposure and the contact exposure, they are assessed in those 5 exposure scenarios, what you see in the middle. Those exposure scenarios, they are based on the EFSA bee guidance for plant protection products, but we had to apply biocide-specific adaptations. And those exposure scenarios, they include intentionally treated area and the contaminated surrounding area. The treated area scenario needs to apply if attractive vegetation is directly exposed to the biocidal product. This is, for example, if the product is used for the large-scale spraying of trees and bushes and larger greenery area. If, on the other hand, you treat non-attractive plants or area, then you could still have bees that are exposed in this treated area because they go to flowers and vegetations that are located in that treated area. And in this case, you would apply the weeds in the treated area scenario. Weeds is now a term that we have used from the EFSA bee guidance, but for biocides, we refer to weeds is referred as mixed vegetation, so flowers, bushes, and grass. And if we have spray drift or runoff after the biocide application to the non-treated area, then in this case, the vegetation margin or the adjacent area scenario needs to be applied. And finally, there's this last exposure scenario at the plants in treated area during the next growing season. This is only relevant for the dietary exposure of bees. When they consume contaminated pollen and nectar. This means that the chemicals, they remain in soil and due to slow degradation over a longer period of time, and therefore newly emerging vegetation will have already be contaminated due to the uptake via their roots. What ends up in the bees will be finally then compared to the toxic effects in bees, and these are the mortality, the brood development, and the sublethal effects. And we have also different timescales. We differentiate between acute and chronic exposure, and those tests are performed both in adult bees and in larvae. For both the exposure assessment and the effect assessment, we have different tiers. The evaluation can be started with the screening or at tier 1. And if you see unacceptable risk, you can further refine either the exposure scenario, either the exposure assessment or the effect assessment. And those refinement options are described in the ECHA bee guidance, and they are similar to the EFSA bee guidance. We propose to first refine the exposure assessment, and then if unacceptable risk still remains, the applicant and the evaluating member state should discuss refinement options on the effect part. However, higher tier studies such as the field studies, the colony feeder studies, and the semi-field studies, they are principally designed for the use of plant protection products. So it could be challenging to use them for biocides. Either they are not technically feasible or directly applicable. Now I'm already coming slowly to the end of my presentation. I will give you a quick overview on the risk assessment scheme for honeybees. As Jana has explained earlier, the risk assessment is only needed for honeybees because there are no protection goals for bumblebees and solitary bees. There is the problem formulation at the beginning, but we can actually just jump into the first diamond, which is the question whether the biocidal product contains an active substance authorized for PT18, or does the substance have an insecticidal mode of action? If no, then no risk assessment is required. If the answer is yes, then it needs to be checked if one of those sources of exposure that I explained earlier is relevant for the intended use of the biocidal product. And again, if the answer is no, no risk assessment is required. If the answer is yes, then the full risk assessment has to be performed with the exposure assessment on one hand and the effect studies on the other side. Later, my colleagues Adriana and Petra will present more details on those assessments. For the lower tier risk assessment, as you see depicted here as the green pathway, you would combine those results from the exposure assessment and the effect assessment. And if the risk is acceptable, the biocidal product is safe for honeybees. If not, then you would need to refine either the exposure side or the effect side. In the middle and on the right, the yellow and blue pathways, they are originating from the effect assessment. These are two additional effect assessments which need to be performed for honeybees. We have the time reinforced toxicity assessment and the sublethal effect assessment. You will hear more about them in the presentation given by Maria. And finally, not depicted in this risk assessment scheme, however required if needed, is the metabolite assessment and the mixture assessment. And Ella will go into more details in her presentation. With this, I am at the end of my presentation. Thank you very much for your attention.
Hello, my name is Adriana Lipkova, and in the next presentation I will give you some overview of the exposure assessment as presented in the biocides guidance on the risk assessment of bees. In the first part, I will present you with the mathematical models which I use to estimate the exposure of bees to the biocides. Take a look first at the figure in the right-hand side at the bottom of this slide. The guidance covers mostly just the exposure due to the consumption of nectar and pollen by bees, which is contaminated by the biocides when using biocides. It does cover also the contact exposure, and this may happen directly due to the use of the biocides when spraying the biocides on the vegetation or on the, for example, on the walls of the buildings. Nevertheless, there are some uses which involve the use of the application of the sewage sludge and the manure on the soil, and this is also in the scope of the guidance. What the guidance doesn't cover is the consumption or the feeding on the guttation water, as well as the feeding on the water which might be in the puddles which may be formed on the soil, whether it's agricultural soil or the grassland when the sewage sludge or manure is being applied. Therefore, there are multiple models to calculate this exposure of bees. There are two dietary models, the so-called above soil model, which covers the contamination of nectar and pollen during flowering. So it's a direct contamination of pollen nectar. Then there is a through soil model to cover the dietary exposure of bees, which considers the residue uptake, the biocides residue uptake from soil, And then eventually, for the contact exposure, there is a contact model, which covers the exposure of bees through physical contact between bees and biocides, which may happen, for instance, when the bee is flying through a shower or the spray, which is during the application of a biocide. Now, in the next slide, I will go through these mathematical models in further detail. So when it comes to the dietary exposure, as said, there are two models. The first one is the above soil model, and the second one is the through soil model. There is a third model also for the dietary exposure of bees, which is covering the pre-flowering contamination, but this is not something which we cover in the ECHA guidance. Nevertheless, it is a model which is covered by the EFSA guidance. We considered that this model is not really relevant for biocides because we rarely know whether the biocidal application happens during the flowering or before the flowering or after the flowering. So we normally assume that there are always plants which are flowering during the time of the application. Now the models are covered here in the middle part of the slide. What we calculate with these models, we calculate so-called predicted exposure quantity due to dietary intake. This quantity is expressed in micrograms per bee, or micrograms per bee per day, or microgram per larvae per developmental period. It refers to the intake of biocide mass per bee. Now, the parameters which contribute to the calculation of this PQ parameter are application rate, which is expressed in grams per hectare. This parameter is somewhat different in the bee guidance compared to the standard assessments that we know on the biocides, because it covers not only the application rate of the substance on a surface, but it refers mostly to the surface of soil and the vegetation growing on that soil. And also it may refer to the release of the active substance on that same surface of soil we covered with vegetation. So while in biocides, often actually we consider something as an application rate, which refers to a surface such as a wall, for instance, or other object. Therefore, one needs to be quite careful. The second parameter contributing to the PQ is the exposure factor for dietary exposure, which is a parameter which relates to the proportion of the applied chemical that deposits on the plants due to either spray drift, dust formation, but it may be related also to the interception by plants which are being affected. It depends on the actually exposure scenario which is used for different source of exposure. So for instance, for treated area scenario, the exposure factor equals 1, but for example, for the vegetation margin scenario, this factor will be lower than 1 because it relates to the drift. For the weeds in the treated area scenario, it may be again below 1 because actually then it refers to the interception. It depends also on the plant growth stage. And then very important parameter affecting the calculation of PQ is so-called shortcut value, which has the same units as the PEC itself. Nevertheless, with the meaning of this shortcut value is, what it represents is it is the 19th percentile of the distribution of the residue intakes by bees, and it is based on the application rate of 1 kilogram active substance per hectare. These shortcut values were calculated with the Monte Carlo method. They are tabulated in the EFSA guidance, and they have there are different parameters, or there are different parameters according to which they are classified. It may be the type of the food, whether it's pollen or nectar. It is the role of the bee. It may be the flowering, the relationship between the flowering time and the application timing, and so on. Nevertheless, it was considered that these shortcut values are relevant also for biocides, and since they are related to the application rate of 1 kilogram of active substance per hectare, they represent the very worst case calculations. Now let's take a look how these shortcut values are calculated. So in the bottom part of the slide, you can see the equations which are used to calculate the shortcut values. The first parameter contributing to these shortcut values are so-called landscape dilution factors, which may be 1 or a little bit below 1. This landscape dilution factor may be below 1 only for the certain bee species. And it also is relevant only for certain exposure scenarios, as well as, furthermore, it is relevant only for the chronic case. The next parameter which contributes to the shortcut value calculation is so-called predicted concentration of the active substance in the pollen or nectar, and it is referring to the situation during flowering. It is related to the again the same unit dose, the same application rate of 1 kilogram of active substance per hectare. The next batch of the parameters contributing to the calculations of shortcut values are CMP and SSN, where CMP is the consumption of sugar or pollen by a bee. So it depends on the bee species primarily, and for the SN, the sugar content, that's a parameter which is expressed in kilograms per kilogram, is also dependent on the bee species, but also on the plant species. And then finally, when it comes to the through soil model, there is also a parameter called predicted environmental concentration in pore water. And for the calculation of the shortcut values for the tier 1 assessments, this PEC pore water is equal to 1 milligram per kilogram. Then for the contact exposure, the model is shown on this slide. There is also in this equation the application rate, which is exactly the same as the one which we had for the dietary exposure. But in addition, there is the exposure factor for contact exposure, which is very similar to the one which I already described previously. Nevertheless, the values are somewhat different, but there are similar dependencies. And then there is a third parameter, which is called BSF, or the body surface factor, which sort of relates the exposure to the size of the bee. So it depends on the bee species. As you may understand, these calculations may be quite complex, and therefore there is also a so-called screening step, which covers the exposure assessment, with which we calculate the same kind of PEQ, but in much more simple way. The models are shown in this slide. But since it covers the worst case situations from the previous tier 1 models, this screening step calculates the worst case PEQ values. So this screening step, maybe to still mention, the screening step is not obligatory. It's optional. It is proposed for some of the sources of exposure covered by the biocides B guidance. So therefore, it is not really relevant for all of the cases. And here are a little bit for the explanation of the parameters which contribute to the calculation of the PEQ for the screening step. Now we go to the second part of this presentation, which is about the relevant sources of exposure for biocides which are covered by the B guidance. These 4 sources of exposure were identified as a part of the screening exercise performed by the expert group, which was covering all of the emission scenario documents for the product types as presented in the BPR, and through also all relevant technical agreements for biocides. A number of criteria were used to derive this list of sources of exposure, such as the scale of the exposure, such as whether it's outdoor use or indoor use, whether there is insecticidal mode of action involved, and so on and so on. So let's go one by one. As for the first one, which is the application of manure or sludge on soil, we refer here only to the use of the biocides, in this case insecticides, in stables and manure storage systems. And when it comes to the use of the sludge or the application of sludge on soil, which is contaminated biocides. With biocides, this is relevant for only for certain animal species, not for the all animal species, which are then studied in the ESD PT18. When it comes to the exposure route, it is the dietary intake which is relevant, but only the through-soil model is to be used, and only one of the exposure scenarios are relevant. So the drift is obviously in this case not relevant, as we assume that actually the manure or sludge is applied on the soil in the treated area, where actually there is no spraying type of application. Now, the next source of an exposure covered by the guidance is the spraying of insecticides, mostly on walls and foundations of buildings, whether these are residential or non-residential. So we again refer to the emission scenario document for PT18. In this case, where the bees may be exposed is actually the band of the soil which is around the building, which is normally assumed to be 0.5 meter from the wall of the building. There, the bees may be exposed in multiple ways. Either it's via dietary intake, where the bee may be actually exposed while it is trying to feed on a nectar or pollen on the plants which are growing in that band of the soil. So that's why we need the above soil model, but also because some amount of the substance will run through to the soil, which is to the same soil. That's why also actually it's possible that there is a substance reaching the flowers of the plant through the uptake of substance from the soil. Therefore, we also need a through soil model. And obviously, since there is a spray drift, also the contact exposure is of relevance. Nevertheless, all of this we can do with one single exposure scenario, and that's the vegetation margin. Then the third source of exposure covered by the guidance is the irrigation of private gardens with treated water with biocides, and this is usually due to to control the mosquitoes. This is covered, or this type of use is covered by the TAP entry 205. Here we assume a situation where we have a private garden and the watering happens either by pouring the water over the plants which are growing in that garden, but also in some cases actually people then watered such gardens actually to the root. Therefore, again, when it comes to the dietary intake, we assume that both of the models, the above soil as well as the through soil model, is relevant. And at the same time, obviously, when we are pouring the water over a plant, then also a contact exposure would be relevant, not necessarily as if it was an overspray situation, but since the bees may be landing on the plants, the contact exposure is relevant. The drift is not relevant, and the treated area, therefore, is the only exposure scenario which is to be used for this type of source of this source of exposure. So the last source of exposure that we cover in the bee guidance is the large-scale spraying. Nevertheless, for this source of spraying, we consider 3 different cases. There is a case A, which is referring to the spraying of specific species of trees. Then there is a case B, where we consider spraying of mixed species of trees and bushes. And the last one is the case C, where we consider spraying of natural water bodies. In the next slides, I will cover these cases one by one, and I will explain how to do the exposure assessment for the 3 cases. So for the first case, which is the case of spraying specific species of trees, this is a type of a use which is covered by the TAP entry 248. It is a type of a use which is typically done by aerial spraying or by ground spraying. But it is intended, for example, in cases of the control of the processionary moth. And for the examples of trees which are being treated are, for example, pine trees or the oak trees. This type of a use is very similar to the pesticidal use. And in this case, we consider that the sources of exposure which are relevant for bees are due to the overspray of the treated trees, where the bees might be feeding on the contaminated trees, namely, of course, the pollen and nectar, which is on the flowers of these trees, but also possibly due to the feeding on the plants which are growing just below the trees, which might be different things. Might be grass, these might be bushes, berries, herbs, whatever. And then also, what is possible is that there is a drift which is taking away part of the spray to the, let's say, adjacent areas around this treated area. At the same time, it is possible that part of the spray will actually reach the soil directly, and then the biocide is available to the roots of the treated plants, and these then biocides are taken up by the roots to the plants, and in the next season this biocide may be there in the flowers, and therefore also in the nectar and pollen on which the bees would be feeding. So in this respect, actually all 4 of the exposure scenarios needs to be covered in the assessment of this case. The treated area scenario, the weeds in the treated area, the vegetation margin scenario, and plants in the treated area during the next growing season. For the treated plants, we may also consider that in some cases the treated plants may not necessarily be attractive, and therefore the treated area scenario may not be necessary to carry out. Also, it's possible that the applicants may have risk mitigation measures that they want to propose, suggesting that some of these scenarios, the calculations and the exposure as found in these scenarios may be lower. Or they might have studies which suggest that actually the default values which we propose in the guidance are lower than what we propose. And of course, it is important to say that all of the 3 models for the exposure need to be used in these assessments. Case B is very similar to case A, but here we consider that we treat mixed species of trees and bushes, and therefore they are always flowering, or we need to consider that some of it is always flowering. They are different sizes, they're different shapes, so it's very difficult to say how the, let's say, other scenarios are affected, how the so-called weeds are affected below the trees, as well as how much of the drift there is in the adjacent areas. So again, this is very worst case scenario, more worst case than the case A. But again, it is important to calculate all 4 of the scenarios, because there might be possibility that in some cases risk mitigation measures may be proposed. For the rest, it's very similar type of a case as a case A. Case C is a case where we consider spraying of natural water bodies. Mostly this is done by aerial applications, or but also possibly by the truck-mounted equipment. It is a scenario which is or it is listed in the ESD for PT18, but it's not. There is no quantitative calculation proposed for this scenario. In this case, although we are treating the water bodies, the water body as such is not a source of exposure for the bees, but there might be drift which is traveling to the banks of the water bodies, and this may be then the source of exposure to bees. We look at this bank of the natural water body as if it was a vegetation margin, and therefore this particular scenario is to be used for the assessment in the case C. As the source of exposure as such is or the root of exposure is the drift, we need to use the dietary model for the above soil and the contact model. With that, I thank you for your attention, and I invite my colleague to talk about the information requirements and the lower tier assessment. Thank you.
Yes, hello. My name is Petra Kunz. I'm working at the Swiss Federal Office for the Environment, and I'm very happy to give you some very fast information on information requirements and lower tier assessment for bees. So I think the main thing on the new effect assessment in lower tiers and the risk assessment in lower tiers for bees is that we have something like a paradigm change, which you will see later. The effect and the risk assessment, they are described in chapters 6 and 7 of the bee guidance, so that you know where you can have a look at it. So before we start, what we first need, of course, are data to do an effect assessment. And as you might all know, the information requirement for active substances and biocidal products are laid down in the Biocidal Products Regulation in Annexes 1 and 2. And normally, toxicity tests related to a certain exposure are the ones we need. And bee studies should in general be provided if the active substance has an insecticidal mode of action and if there is a relevant exposure of a biocidal product to bees. So mandatory requirement is always data on honeybees. Data on bumblebees and solitary bees may be requested if relevant for the assessment, but they don't have to be provided. So currently there are several test guidelines available, as you can see. For honeybees, we have 4 different OECD validated test guidelines, one for acute oral toxicity, one for contact toxicity, then we have a chronic test guideline, and one for larvae. For bumblebees, we have also the 2 acute test guidelines. But also, what you also can see is that we have a lot of test guidelines missing, especially for solitary bees. The good news is here that for the acute oral and acute contact toxicity for solitary bees, these tests are currently validated under the OECD, so there will be test guidelines available in the future. And for most of the other missing test guidelines, so all the chronic and larvae toxicity for bumblebees and solitary bees, there are at least proposals available for possible test protocols. So in general, the tests we consider for an effect assessment are OECD test guidelines, but also existing protocols which are not yet validated, and also relevant information from public literature and non-guideline studies. Now, if we want to do an effect assessment, what kind of data do we always have to have? And this you can see here. So, and this would be the case for honeybees. So we always need the 4 toxicity studies for honeybees, so the 2 acute studies, as well as the chronic and the larvae study. This is always needed if the active substance or the biocidal product has an insecticidal mode of action. And what we also need is an acute study for the formulation. The reason for this is that we want to make sure that the formulation is not more toxic than the active substance. And this we see if the LD50 of the active substance is divided by the LD50 of the biocidal product, if this is bigger than 3. Then we know that the formulation has a higher toxicity which has to be considered. And then we also request a chronic oral toxicity study and a study with larvae for the formulation. Also, and this is a special case, if we have a formulation with 2 or more active substances with an insecticidal mode of action, so we have a mixture, then we always need all 4 studies also for the biocidal product to do our mixture assessment. So with all this information, I like to come to the main thing that changed, which is a paradigm change in how we do the effect assessment for bees compared to the effect assessment we do normally and the risk assessment for biocides. So in our traditional risk assessment we do for biocides, we use the most sensitive endpoint we have. Then we use an assessment factor and derive the predicted no effect concentration. And we also have a predicted environmental concentration. In the new risk assessment for bees, we go very new roads, so to say. We use, instead of the one most sensitive endpoint, we use raw data of all available studies. So these 4 studies I showed you before. We use dose response analysis to derive the effect parameters. These are in our case the LD50 or inflection point and the slope of the dose response. And then together with the predicted exposure quantity, we calculate an individual risk. And this individual risk is then extrapolated to the colony or population level. And also, not like we do it normally for biocides, we do not look at the PEG-PNEC, but to assess the risk, we aggregate all the effects we have in a response addition, and then we compare the combined response to the specific protection goal of 10%. So now I would like to just show you how this is done. So it's done in 3 steps. Afterwards, I will go a little bit in more detail for each step, but the 3 steps mainly are: first, we quantify the individual level effect concentration. We do this with our laboratory tests we have and with our standard exposure estimates. As soon as we have the individual effects, we extrapolate to from the individual to the colony level, because for bees live in colonies. And then with the extrapolated effect, we aggregate or combine all risks at the colony level and get the predicted effect at the specific protection goal level. So we combine all effects into one single predicted effect. And now I would like to show you a little bit in more detail how this is done. So first we calculate the effects at the individual level. So the goal is to calculate the predicted individual level effect. And in order to do this, we need a realistic worst case exposure we get from our exposure calculations. We start with our raw data, for example, for chronic toxicity. And you can imagine here some dots for the raw data, and over these data points, we fit a nonlinear dose response curve. And this fit gives us an inflection point, or the LD50, but it also gives us the slope of the dose response curve. So the 2 parameters which describe the dose response and our effects. Then we use the predicted environmental concentration to calculate the predicted individual effect with our dose response analysis or function. And in this case here, we get the predicted individual effect of 20%. So in this case, the substance or biocidal product in question would lead to 20% mortality in a chronic study. Now, the next step, as I mentioned already, is to make the lower tier risk assessment compliant with the SPG. And in order to do this, we have to extrapolate from the individual level to a higher level of biological organization. And in the case of honeybees, this higher level is the colony. And we also have the SPG, our specific protection goal of 10% is at the colony level. So EFSA did a lot of simulations to see what extrapolation factor is needed. So they looked at different tests, different times of the year, as well as different locations where the bees have been held. And what they found that the extrapolation factor of 1 sufficiently covers the risk in a lower tier approach. So in step 2, we basically don't have to do much. We have to multiply our predicted individual effect by 1 to get the predicted colony effect. In the third step, finally, now we are dealing or encountering the third paradigm change. And here we combine all the effects we observe at the colony level by a model. And the rationale to do this is that under real world conditions, effects are adding up at colony levels where our specific protection goal is set. So for example, we can assume that acute and chronic and larvae toxicity will add up. But as these toxicities act on different endpoints, the maximal possible effect cannot be more than 100%. So we have the effects at our 4 risk cases, and these are now combined by using a mathematical model, which is called the response addition, which is normally used for mixture toxicity of substances. But it can also be used, of course, for this. And this will give us the predicted effect at colony level. So to give you a small overview before we finish or wrap up, is we have the exposure, predicted exposure quantity. We have our effect parameters, and we use them in step 1 to calculate the predicted individual level effect. Then we extrapolate in step 2 by an extrapolation factor of 1 to the colony level. And in step 3, we combine all the predicted colony effects. Now, what is still missing is, of course, our step 4, and there we would like to compare the overall effect at the colony level with the specific protection goal of 10% for honeybees. And if it's higher, then we have a risk, of course, and if lower, there is no risk. So as a last slide, I would show you would like to show you a small example how this could look like. Here you can see a risk assessment for honeybees based on the exposure is a dietary exposure through soil contamination and contact. And you can see here the 4 risk cases. So 3 dietary risk cases: acute dietary toxicity, chronic dietary toxicity, and larvae toxicity. And then also our contact risk case, which is the acute contact toxicity. In the green row, you can see the predicted exposure quantities. And what you can see here is that larvae have a slightly higher exposure than all the others. And what you might also have seen is that for the acute contact toxicity, we don't have any exposure here. And the reason for this is because this is a through soil model. So it is assumed that the active substance or biocide is taken up by plant roots, and therefore there is no contact exposure. In the green row, you can see all our, in the yellow row, I'm sorry, you can see all our effect parameters. You can see which dose response model has been used, in this case, the log logistic. Then you see the LD50 for each of our risk cases, and the slope, so the steepness of the curves, of the different curves. And now with the exposure and the effect parameters, we go to step 1, where we calculate the predicted individual level effect. What you can see here already, which is quite interesting, is that larvae toxicity, or the effect on larvae, is much, much higher than all the other effects. Of course, this stays if we extrapolate with a factor of 1 to the step 2. So we still have larvae with the highest effect. And then in step 3, we combine all the effects at the colony level. And you can see here the model and the calculation. And as you can see, the model gives us a 11.18% of predicted effect at the colony level. So this is above the specific protection goal of 10%. So the specific protection goal is not met. And we, in this case, an unacceptable risk is identified. And this would lead to further refinement of the predicted exposure quantity for the dietary model for through soil contamination. So I hope with this small example and my explanations, the lower tier effect and risk assessment for bees is a little bit clearer to you. And I thank you very much for your attention.
So, hello everybody. I'm Maria Marca from the Swiss Federal Office for the Environment, and I will give you an overview of the chapters 8 and 9 of the bee guidance, which deal with the time-reinforced toxicity and sublethal effects respectively. So I start with the chapter 8 on the time-reinforced toxicity, in short TRT. So first of all, what is the concept of time-reinforced toxicity and what is the issue to be solved? So the concept of TRT is the potential of the active substance that are assessed for the risk to bees to show increasing toxic effects due to long-term exposure to low doses. Sorry. So what is the issue of TRT? To identify if the toxic active substance presents TRT properties, the data of the standard chronic toxicity test, the OECD test guideline 245, is used. And in this test, the bees are exposed up to 10 days. The standard hazard or the effect assessment is based on the standard studies with fixed exposure durations. And this approach is valid if the toxicity is dependent on the dose. However, if substance shows TRT properties, the toxicity is dependent on the duration of exposure. So thus, if the toxic effects of biocides at low doses over a long-term exposure period are higher than the effects of higher doses over a short exposure period, then the substance shows TRT properties. In this case, and if this is the case, the toxicity of the low doses may be underestimated in the standard lower tier risk assessment for bees. And this is why it was decided to test whether TRT could be an issue for the biocidal active substance. So why might TRT be also an issue for biocides? Firstly, according to the types of biocidal application that are considered in this guidance, it is quite possible that bees will be exposed to low doses of biocides for a period longer than the 10 days of the standard chronic toxicity test, or even for the entire lifespan of the bees. And in addition, the guidance focused primarily on biocidal active substance with an insecticidal mode of action with relevant exposure to bees. And it is therefore important to assume that they may have these TRT properties on bees. And finally, as the properties and mode of action of biocidal active substance may be similar or identical to active substance in plant protection products, it was therefore decided to take over the assessment of the time-reinforced toxicity from the guidance on the risk assessment of plant protection products on bees, that is the EFSA B guidance. So now I'm going to give you a very brief overview of the TRT scheme. The TRT assessment is divided in two main parts. The assessment begins with the hazard assessment part on the left side, where the data from the standard 10-day chronic toxicity study are used to determine whether the active substance has TRT properties. And in the second part, which is the actual risk assessment for substance identified as having these TRT properties in the hazard assessment part. And for the hazard assessment part, the data from the standard 10-day chronic toxicity study is required in the first instance. And this is why the TRT assessment can be only carried out for honeybees and not for bumblebees or solitary bees, for which there are currently no standard guidelines to test this chronic toxicity. So I will very quickly go through the different steps of the hazard assessment first, without going into details. So in the hazard, in the hazard assessment part, the question to be answered is: does the evaluated substance show time-reinforced toxicity properties? And this part is divided in 4 steps. The first step is to determine if the TRT assessment is necessary using the mortality data of the 10-day chronic test. These steps ensure that the test substance with a relatively low toxicity are not tested for their TRT properties. So it's a screening step, sorry. And if the TRT properties have to be tested in the second step, it has to be checked if the mortality data from, again, this 10-day chronic test are good enough to fit in the GUTS models. So the GUTS stands for General Unified Threshold Model of Survival. And these are the models that are used to determine the LDD, so the lethal dietary dose values, to estimate the TRT properties. And then in the third step, if the data is good enough fitting the GUTS models, allows to extrapolate the data from the 10-day chronic test to estimate dose response over the lifespan of honeybees. That is the 20-day LDD 50 value. So the 27-day correspond to lifespan of a summer bee. And in the fourth step, then it can be determined whether the substance shows TRT properties by comparing the dose-response relationship, that is the 10-day and the 27-day LDD values derived from the GUTS models. So that is for the hazard part. And then if the TRT properties are identified in the hazard part, as other hazard assessment part, the TRT risk assessment has to be performed. So using the GUTS models, the lifespan dose responses are calculated for two different scenarios. The summer B scenario, for which the lifespan is estimated at 27 days, and the winter B scenario, for which the lifespan is estimated to 182 days. And finally, the lifespan dose responses obtained with this risk assessment substitute the 10-day dose response in the lower tier assessment to predict finally the overall effect of the substance, including the TRT properties. So that was it for the chapter 8 on the time-reinforced toxicity. And now I will continue directly by giving you an overview of chapter 9 of the guidance on the sublethal effects. So first of all, how are the sublethal effects defined? Sublethal effects are biological, physiological, demographic, or behavioral effects on an individual or population that survives exposure to a substance at a lethal or sublethal concentration, meaning that it does not cause a direct death of the bees. Consequently, it is not possible to establish a direct link between the sublethal effects and the specific protection goals of less than 10% reduction in the bee colony strength, which are then based on mortality endpoints. And it is very important to note this point for the outcome of the sublethal effect assessment. So it was decided in line with the EFSA bee guidance to follow the same strategy for assessing the sublethal effects of biocidal active substance. But why are the sublethal effects also relevant for biocides? Well, sublethal effects can affect several endpoints, such as development, fertility, or foraging behavior of the bees, which can potentially impair the colony strength of honeybees. Furthermore, the concern on the sublethal effect has increased in recent years, and there is a growing amount of data from the open literature showing sublethal effects on the wild or managed bee populations, and there's a real potential to impair honeybee colony strength through these sublethal effects. So which endpoints are evaluated during the sublethal effect assessment? There is a broad range of adverse sublethal effects that have been reported and listed in the Annex K of the EFSA bee guidance. And to address the sublethal effect assessment of bees, it was decided to focus on sublethal effects altering the bee foraging behavior, as any negative impact on foraging can closely be linked to the colony strength of the honeybees. And in addition, the effects on foraging behavior can be observed also in the available standard toxicity tests by assessing the behavioral abnormalities from this data. Thus, the data of the required standard toxicity test are used for the sublethal effect assessment, And in addition, as the standard toxicity tests are mainly available for honeybees, it was decided to limit this assessment of sublethal effects to honeybees. So I'm now going to give you a very quick overview of the strategy and the data required for the sublethal effect assessment. The assessment is divided in 5 steps. The first step is a screening step using the data from the standard laboratory toxicity tests to check if the sublethal effect assessment is necessary. If this screening step reveals a concern for sublethal effect, the standard toxicity tests are used this time with an assessment of the behavioral data from these tests. And if this second step identifies again a concern for sublethal effect, specific assays to assess foraging behavior must be performed in the third step. And if the data from these specific assays show concern for sublethal effects, so the tier assessment goes further, and in the step 4, a specific standard field study can be used. That is the homing flight study that can be performed. And it can go further also to the 5th step by using field studies if available. So finally, to conclude on the presentation on sublethal effect assessment, you may have noticed that I've only mentioned the term concern and not risk for the sublethal effect assessment. This is because as it is not currently possible to establish this direct link between the sublethal effects and the specific protection goals, the outcome of the sublethal effect assessment will be either concern for sublethal effect indicated or no concern for sublethal effect indicated. And if there is a concern, there may be regulatory consequences, but this is still in discussion at the moment. And with that, I've finished my presentations on TRT and sublethal effects, and I thank you for your attention.
Good day. My name is Ella Laakkonen, and I will start my presentation with the approach for metabolites and mixtures. Let's look into the metabolites first and where to start from. For biocides, an environmental risk assessment should be performed for the active substance as well as their metabolites, as is stated in Biocidal Product Regulation, Annex 6. Metabolites are a concern when they are found in plant materials, such as pollen, nectar, or other plant matrices that are attractive to bees. For biocide applications, the assessment of metabolites in these plant materials is not a standard practice. BPR Annex 2 includes information requirements for biodegradation and transformation in water, manure, soil, and air. However, the information requirement in BPR Annex 2, 10.4, meaning the endpoint additional studies on fate and behavior in the environment, is to support the approval of an active substance. This information requirement includes any relevant compartment or matrix. Also, for metabolites, the same holds true as in the active substance assessment, meaning when there is exposure to bees, the risk assessment is triggered and measured metabolite data in relevant matrices may be required. However, as experience with the generation of relevant metabolite data in plant matrices is very limited for biocides, and the risk assessment for the active substance often covers metabolites, a stepwise approach depending on the source and scale of exposure, is used for the metabolite risk assessment. Here we will have a closer look at the metabolite assessment decision tree. We will focus on the starting point, which is the source of exposure, as metabolite risk assessment is only required for larger scale applications, including large-scale spraying, irrigation and manure or sludge applications. The decision tree is split into two paths. The left side is for large-scale spraying and irrigation, and the right side for manure and sludge applications. Both of these paths have two screening steps. In the first step, you check if the risk for the active substance is acceptable. If it is not, then no further metabolite assessment is needed. However, if the risk for the parent active substance is acceptable, then a screening for any potential metabolites is done by assuming a 10 times higher toxicity compared to the parent. Only if the risk is unacceptable, further data are required. Then, good to note that the approach for manure and sludge applications has small differences compared to the spraying done with the metabolites. As the potential metabolite screening for the manure and sludge application is done with the metabolites formed in soil. This information can be obtained from the standard assessment for the terrestrial compartment. Also, here in the first pore water calculations, the pore water concentration can be refined to see if the risk could be controlled. If based on these calculations, an unacceptable risk is still identified, further data are required, investigating the uptake characteristics of these metabolites in plants, pollen and nectar, and/or the toxicity of the relevant metabolites to bees. However, note that if either of these paths, so the large-scale spraying and manure or sludge applications, it results in an unacceptable risk, the applicants should contact their evaluating competent authority prior conducting any study and submitting their dossier. It's good to note that the information requirements on metabolites are in principle the same as for the parent active substance. However, the acute contact study is not considered relevant, as exposure to metabolites in nectar and pollen via contact is negligible. Then, to conclude on this topic, something we need to consider for the future. In general, there is a need to gain more experience on the metabolite risk assessment for bees. It is currently uncertain if the calculations sufficiently represent the actual situation in the field, as metabolite residue data in pollen and nectar are lacking for biocidal uses. In addition, the lack of instructions for testing also affects the assessment of metabolites. With this slide, we will change the topic to the mixture assessment for honeybees. It is required only if there are 2 or more active substances with an insecticidal mode of action present in a biocidal product. However, note that the risk assessment is not triggered if an active substance with non-insecticidal mode of action is part of a biocidal product. For example, when an active substance is a co-formulant. The scheme is a novel approach for mixtures, but it is in line with the EFSA method. However, it's simplified for biocides. Remember that the effect studies are always required for biocidal products containing 2 or more active substances. Thus, in most cases, the risk will be estimated using measured mixture toxicity, unless experimental testing of the product is technically not feasible. Then, based on the mixture toxicity values for each risk case, which are acute contact, acute dietary, chronic dietary, and larvae dietary, a combined mixture risk assessment can be conducted in line with the approach presented in the guidance. All right, here we can take a look on the flowchart illustrating the risk assessment scheme for mixtures. As it has quite many steps and options, I will not go through it in great detail. You will find all the instructions on how to conduct the mixture toxicity assessment with all the steps written out and explained in detail in the guidance. Now I will just emphasize that the scheme is to be repeated for each risk case. Those were acute contact, acute dietary, chronic dietary, and larvae dietary. The first step is to see if measured product data is available. If it is, then the next step is to derive the model deviation ratio by comparing the calculated mixture toxicity against the measured mixture toxicity. And this is done to determine if the active substance may have synergistic or antagonistic effects. If the model deviation ratio is between 0.33 and 3, it means that the dose addition hypothesis holds, and you can use the measured dose response curve for the risk assessment to calculate the overall predicted effect at colony level. Then you compare that result to the specific protection goal and conclude on either acceptable or unacceptable risk. Next, we will move on to the summary and recommendations for future. So, to summarize the content of the webinar, it's good to remember that the ECHA guidance was developed by considering the EFSA guidance for the plant protection products. Of course, we made biocide-specific adaptations. The ECHA guidance is applicable for sources of emissions belonging to product type 18 uses. And the assessment is currently only for honeybees, as there are no agreed specific protection goals for bumblebees and solitary bees. Sublethal effects and time-reinforced toxicity assessments are new elements for biocides. And remember that the risk needs to comply with the specific protection goals and not with the PEC-PNEC risk ratio. Now, here are our considerations for future research and development needs. Currently, there are significant data gaps regarding non-bee pollinators, and information on the ecology, species sensitivities, and most relevant routes of exposure is needed. Also, validated standard test guidelines are needed for non-bee pollinators. Furthermore, we need to consider the inclusion of potentially important matrices, exposure routes, and life stages to cater for species that, for example, use leaf cuttings or mud as nesting material. In addition to non-bee pollinators, we also need validated test guidelines for bumblebees and solitary bees. And in general, experience is needed in relation to both higher tier studies and higher tier risk assessment for bees in the biocide field. Especially regarding field studies, as it's unlikely that field studies, according to the current test guidelines, would be conducted for biocides. Finally, I conclude this presentation with implications and next steps. The newly published guidance brings a new risk assessment methodology and new data requirements for the biocide assessment for bees. This means that new skills are required from both industry and authorities. However, ECHA is working to build a calculator tool which will help in conducting the risk assessment. The new guidance also means that risks to bees are assessed more consistently and robustly. In the bigger picture, all these actions mean that pollinators are better protected. We also note that for non-bee pollinators, a quantitative risk assessment methodology is needed. Before this can happen, there is a need to further research generate research and generate data so that we can make informed science-based decisions. Now I have reached the end of my presentation and I will hand the floor to my colleague Adam, who will explain the practicalities regarding the questions and answers session. I thank you for your attention.
Thank you to all our presenters. Now it's time to start our live Q&A. As mentioned at the start of the event, you can send us your questions through Slido using the QR code on this slide, or by going to slido.com and using the event code ECHA. The live Q&A lasts until 1 o'clock, after which we end the webinar. Now remember that if your question is not answered by the end of the event, we will be publishing the Q&A with answers to all the questions soon. So, without further ado, I'll now hand over the floor to Ella, who will be moderating the Q&A, as well as the experts who are here to reply to your questions. We'll start shortly.
Hello, I am Ella Laakkonen and I will be your moderator today. Our panel is made up of today's presenters Jaana Laitinen, Tenzin Gyalpo, Petra Kunz, and also of two additional experts, Ricardo Schöps from the German Environment Agency, UBA, and Marta Kainsos-Garcia from the European Commission. Ricardo is an expert on exposure assessment, whereas Marta can elaborate on the policy aspects and implementation of the guidance. Thank you for sending us your questions in advance. We will be replying to a mix of those, as well as the ones you have sent in during the presentations, and of course now during the Q&A. We would like to remind you that the scope of these questions and answers is the overall risk assessment scheme for bees, the new information requirements, the exposure assessment from the use of biocides, and the specific aspects of the bee risk assessment. All questions received today and within the scope of the webinar will be answered in the Q&A document that will be published soon. So if your question is not answered during this event, check the published Q&A. Okay, let's get started. The first question relates to the calculator tool, and it will go to Petra. And the question is, will a calculator be available and what data will be needed for this? EFSA are developing a calculator for the risk assessment due to the complexity. The slope and intercept for calculating the pi-j from the exposure depends on the model and software used. How will this be assessed? Petra, please.
Yes, thank you, Ella, and good morning, everybody. So ECHA is currently working on the calculator, and for the calculator, raw data will be needed to derive the LD50, intercept, and the slope, and then as well we will use the exposure estimates. The calculator tool itself will use 4 nonlinear regression models. So it's the hill, the log normal, Weibull 1 and Weibull 2, and this will all be incorporated in the calculator.
Thank you, Petra. It's answered. And then the next question will go to Marta, and it relates to the applicability of the guidance. And the question is, when do the companies and authorities need to start applying the guidance for active substances and products? Marta, please.
Thank you, Ella, and good morning to all. So the date of applicability of the guidance is still under discussion with the competent authorities for biocides. But for the comments we gather from member states, we would propose that this guidance would not be applicable for active substances under the review program. And this is in line with the agreement reached in the competent authorities meeting of not applying new guidance to the active substances in the review program. And it will be also not applicable to ongoing procedures. And the guidance will be applicable to all new procedures for products or active substances that will be submitted 2 years after the publication. And this is 1st February 2026. Thank you.
Thank you, Marta. And we also have another question relating to the same thing, so I will highlight it now. I don't know if you have anything more to add, but yeah, the question is, Marta, hi, as of what date will it become mandatory to address the risks of biocides to bees in an environmental risk assessment? Do you have anything to add, Marta?
Yes, the date, well, my reply is applicable here also. So it will be applicable, sorry, in 2 years for new procedures for which an application is submitted in 2 years' time, so in February 2026. And it will not be applicable in the meantime, so for ongoing procedures and for active substances in the review program.
Thank you, Marta.
Thank you.
And then the next question relates to nonlinear regression equations, and it goes to Petra. And the question is, hello, the EFSA guidance uses only nonlinear regression equations, but studies are usually analyzed during linear regression statistics. Can the calculator tool include linear regression equations as an option, as the parameters are different? Petra, please.
Yes, thank you, Ella. No, the calculator will be developed by ECHA, and also the calculator tool by EFSA will use only nonlinear regression models. They will use 4 different models, as I mentioned already. And the nonlinear regression models, they have the advantage that they use more information of the data itself, and also they avoid using inaccurate assumptions, which is sometimes made by linear models.
Thank you, Petra. Okay. And then also the next question will go to you, Petra. And the question is, will ECHA develop Excel sheets or another tool for performing the risk assessment? If so, when will it be available? Yeah, Petra, please.
Sorry. Yes, ECHA will develop a calculator tool, and it will be available as soon as this tool is ready. So there are no certain dates yet. And with this tool, all the calculations can be done.
Thank you, Petra. Our next question relates to emission scenarios, and it will go to Ricardo. And the question is, how will the revision of ESD PT18 impact the bee guidance?
Thank you, Ella. Also, good morning from my side. This is a quite specific question, but yeah, this ESD PT18 is still under revision, and we cannot say how it exactly will be implemented. But if it's ready for it, then this will be done like in Korrigendung of the ECHA guidance, or as for other scenarios, like adding a tab entry for it. And yeah, this will be done then in this specific case. Thank you.
Thank you, Ricardo. And also the next question goes to you. So the question is, For indoor uses, we have also emission to STP, and then to sewage sludge is put on the grassland and arable land. And similar to sewage sludge from animal housing, bees can be exposed. However, this is not considered in the guidance as a source of exposure. Could you please clarify this? Please, Ricardo.
Yeah, thank you for pointing this out. However, this question was also assessed in detail during the guidance development. And yeah, we have done emissions calculation for the active substance for stables and also for household products. And for household products, there was always acceptable risk in contrast found to the stable use. And so also like in the households, they use like stickers or something like this, where the emission is not really it's negligible. So this is not considered. That's why it's not considered in the guidance. Yeah, thank you.
Thank you, Ricardo. All right, and then the next question we will take relating to the non-bee pollinators, and it will go to Jaana. And the question is, what are the next steps in the preparation of non-bee pollinator guidance? Jaana, please.
Thank you, Ella. So indeed, as was mentioned in the presentation, in the first step of this ECHA guidance process, it was not possible to prepare a guidance due to many data gaps that were identified, for example, related to the basic biology and ecology of the non-bee pollinators, and more information would be first needed, for example, on the exposure routes and the most sensitive life stages of the non-bee pollinators. And these questions are currently investigated in a number of scientific projects that are already ongoing by EFSA and other organizations, and they are collecting information on these topics and try to develop the methods for the non-bee pollinators. So at the moment, we are not able to say when exactly we are able to develop a guidance for biocides, but anyway, the work is already ongoing, so it will be coming in the future.
Thank you, Jaana. And then the next question relates to risk mitigation measures, and it goes to Ricardo. And the question is, when risk mitigation measures are proposed by the applicant at tier 1 or at later tier, should we still calculate the risk? How integrate the proposed RMM to determine if they really reduce the risk? Ricardo, please.
Yeah, thank you for this question. It would be like the other way around. So first, as in the normal procedure, you calculate the tier 1 or do the screening step, and then you calculated the risk. Then from that risk, you can set risk mitigation measure. And so far as the development of the guidance is now finished, we do not have a complete list for specific risk mitigation measures. So that's why we cannot say how it will be done in the future. Thank you.
Thank you. Then the next question relates to the calculator tool and the GUTS modeling, and it will go to Jaana. And the question is, will the GUTS modeling be incorporated into a calculator tool provided by ECHA? Jaana, please.
Thank you. So currently ECHA or EFSA is developing their calculator tool for the plant protection products, and they will include the GUTS model in their tool. And when we will prepare the tool for biocides, also in our tool, the GUTS model will be included. So it will be there.
Thank you, Jaana. And our next question relates to information requirements, and it will go to Petra. And the question goes, chronic tests will only be required if acute toxicity tests are positive. Doesn't this risk overlooking effects of active substance that have only chronic effects? Petra, please.
Yes, thank you. That's a very good question. We hope not that this is the case, but of course, depending on certain endpoints, this could be the case. But I think with the current set of data we have now, and we have a chronic test in the data requirements for honeybee, we will at least pick up the most important chronic effects.
Thank you, Petra. And the next question relates to the scope of the guidance. It will go to Tenzing. And the question is the bee guidance only relevant for PT18 substances or also for substances with insecticidal mode such as PT19 and PT8? Tenzing, please. You're muted, Tenzing.
Thank you for this question. Yes, so for PT19 products, there are active substances that are authorized or notified for both PT19 and PT18. So those substances have an insecticidal mode of action. However, those products sprayed outdoors in a larger scale, their intent is to repel the insects and not to kill. So for repellent products in the efficacy studies, there's a provision to show that don't have a killing effect. Therefore, the level of exposure is much lower than for PT18 uses. And for PT8, yes, there are also insecticides used. And for example, if you have a spray application around the house for PT8, we have already the source of exposure with the wall scenario. So you could you would apply this scenario for a PT8 product that is sprayed outdoors. Thank you.
Thank you, Tenzing. And then the next question relates to higher tier risk assessment, and it goes to Petra. And the question is it possible to perform a higher tier risk assessment for biocides? Petra, please.
Thank you, Ella. So with regard to the higher tier assessment, the problem is a little bit that studies are usually designed for plant protection products, and they cannot be, most of the time, not directly be applied to biocides, especially if it is about field studies. So the higher tier risk assessment is always done case by case, and companies are advised to discuss this with their competent authorities. In the first version of the ECHA bee guidance, the section on higher tier studies is quite short, but we hope that once we gained experience on bee risk assessment, we can give more detailed recommendations how to do this. Thank you.
Thank you, Petra. And then the next question also goes to Petra, to you, and it relates to information requirements. And the question goes, which toxicity studies are a mandatory requirement? Petra, please.
Yes, thank you, Ella. Again, so data on honeybees are always mandatory for biocidal products with an insecticidal mode of action. For the active substances, acute oral and contact, chronic oral and larvae toxicity are necessary. And for the biocidal product, we always need to have acute data to see if the product could be more toxic than the active substance. If we have formulations with more than 2 active substances, then also honeybee data for the biocidal product are mandatory. Thank you.
Thank you, Petra. Let's see then for the next question, it will go to Jana, and it relates to the sublethal effects. And the question is, are there any proposals from the expert group for the regulatory consequences when the outcome of the sublethal assessment is concern for sublethal effects? Jana, please.
Thank you, Ella. So this topic has been discussed in the expert group and already to some extent with the competent authorities of biocides, but at the moment we don't have concrete proposals yet. So the discussion is still open. and there is also a similar discussion ongoing for the plant protection products. So at the moment, we are not able to provide this kind of proposals, and it will be coming in the future. Thank you.
Thank you, Jana. And the next question goes to Marta. It relates to product authorizations, and the question is, at product authorization level, if no data on active substance is available, for example, active substance approved before the entry in force of this guidance, how it will be managed the comparison of the acute endpoints? Marta, please.
Thank you, Ella. So yes, I already clarified that the date of applicability is still under discussion. So our proposal is that it will apply for applications submitted 2 years after the publication, with the exemption of active substances in the review program. So yes, it can happen that you have a product application for which this has not been sorted out in the active substance approval. And applicants will need to submit the data in the context of the product authorization. And then discussions will take place in the BPC working groups to decide whether this new data would lead to an amendment of the listing of endpoints of the active substance or not. So yes, this will be assessed in the context of the product authorization.
Thank you, Marta. Then our next question will go to Ricardo, and it relates to irrigation water. And the question goes, the direct uptake of treated irrigation water is not included. In dry and warm periods, and in case there is no sufficient clean water source, this can be a highly relevant source of exposure to honeybees. Ricardo, please.
Yeah, thank you. Yes, that's true. But the consumption of, for example, like this contaminated water was currently not considered in this in the ECHA guidance, but because of lack of data also. But it might become relevant in the future when there is more knowledge gained or acquired. Thank you.
Thank you, Ricardo. We have time for a couple of more. Let me take the next question that relates to the risk at screening step. It will go to Tenzing. And the question is, if there is not a risk at screening step, are tests still mandatory? Tenzing, please.
Yes, so the screening step only relates to the exposure assessment. So if you conclude already a risk, you have already performed the effect studies. So the effect studies you always need to perform, and then you combine it with the screening step or tier 1 of the exposure assessment. So therefore, tests are always required.
Thank you, Tenzing. Then the next question relates to new approach methodologies, and it goes to Jana. And the question is, how is the new bee guidance from ECHA related to the implementation and utilization of new approach methodologies in bee testing? Are there specific provisions or considerations within the guidance that addresses the integration of NAM techniques, and if so, how will they be applied in practice? Jana, please.
Thank you. This is a good question. In this first version of the ECHA bee guidance, it was not possible to take into consideration these NAMs, since this is information that is still under development and will be possible to implement only in the future. But there are other projects ongoing that are already looking into this topic. For example, the IPOL-ERA project, that is where the objective is to advance the chemical risk assessment of pesticides, biocides, also other chemicals for the insect pollinators. And in the scope of this project, also the NAMs are addressed and checked how to implement those or how the risk assessment could be improved with the NAMs. Thank you.
Thank you, Jana. And then the next question I will also give to Jana, and it relates to the bumblebees and the solitary bees. So the question is a risk assessment needed for bumblebees and solitary bees? Jana, please.
Yes, so the risk assessment scheme in the guidance, which is provided for honeybees, is also applicable to bumblebees and solitary bees, but at the moment we don't have the specific protection goal defined yet, so it's not possible to fully implement the scheme at the moment. And also the test guidelines are not available yet for all the endpoints for bumblebees and solitary bees. So due to this lack of information, there are uncertainties related to the assessment of bumblebees and solitary bees. But in any case, if the evaluating competent authority thinks that it would be necessary for a certain biocide active substance, they can anyway request that data in certain cases. So that's the status at the moment. Thank you.
Thank you, Jana. And now we have time for one last question, and it will go to Tenzing. And the question relates to product types. And the question is, in the summary slide, it was stated that this guidance only concerns PT18 users. However, could other PT18 be of concern? Tenzing, please.
Yes, so in the first version, it's correct that we only look into PT18 users. However, if we have other intended users which potentially lead to exposure to bees, of course, they could be assessed in the future. As I stated earlier, for example, for PT8, spray treatment around the house, that could be already assessed with the current approach presented in the ECHA guidance. But revisions and adaptations for future sources of exposure, which could be relevant, is always possible.
Thank you, Tenzing. And now it's time for us to conclude the Q&A. We thank everyone for attending from our side, and we hope that this webinar has been helpful. Thank you.